guys, time to talk about some concepts of chemical bonding. Chapter 8, we're going to cover sections 1 through 4 in this video. Okay, 3 types of chemical bonds. Ionic bonds, which are a positive and negative electrostatic attraction. You guys know that. Covalent bonds, which share their electrons. You also know that. And metallic bonds, where the metal atoms are bonded to several other atoms. What we're going to cover in this is the ionics and the covalents. Okay? Okay, ionic bonding. Energetics of ionic bonding, that just means the energy of bonding in ionic bonds. It takes 495 kilojoules to remove an electron from sodium. We saw that in the last video, I think, okay, when we talked about ionization energy. We get 349 kilojoules by giving electrons to chlorine. So chlorine has an electron affinity. It's one that really wants electrons of negative 349. And remember, the more negative the electron affinity, the more it wants the electrons. But what we find out is that this is a very exothermic, look at all this heat coming off here. When we mix chlorine and put it with a chunk of sodium, that's what this is, and we get sodium chloride, it's very exothermic, and what we just showed you with the numbers doesn't explain that. So there's a third part, and the third part is that you have these two negative ions that are attracted to each other. Okay, so part 3, sorry you can't see the beginning of the word part, that this says part right here. Part 3 is electrostatic attraction and lattice energy. Okay, we're going to talk about that a little bit. Lattice energy, what is it? Lattice energy is the energy required to completely separate a mole, 1 mole, of a solid ionic compound into its gaseous ion. So it goes from a solid to a gas, 1 mole of it. Okay? Coulomb's law governs the energy associated with electrostatic attractions. And we use this crazy equation, okay, which we will talk about more in class. But Q here stands for charge, okay? And then K is going to be a constant, and D is going to be a distance. All right, lattice energy increases with the charge on the ions, and it increases with the decreasing size of the ions. This table actually already has them put together. Okay, you don't see any ions as they are by themselves. You see the compound, and you see then its lattice energy. And we'll know more about size as we continue, so this will make more sense as we move on. And then this chart is just showing you, it's another one of those energy charts, is putting this all together and showing you that you start out with your sodium and your chlorine, and you have all these different exchanges of energy. You have the gas energy to form the sodium chloride. You have the energy that comes from the electrostatic attraction, okay? You have the heat of formation of sodium chloride, and all of that in the end, you get an overall